Let's solve practice set 3.3. Question first. In figure, points G, D, E, F are concyclic points of a circle with center C. Angle ECF equals 70 degree. Measure of arc DGF equals 200 degree. Measure of arc DGF equals 200 degree. Find measure of arc DE and measure of arc DEF. Measure of arc DE and measure of arc DEF. Okay. Now from figure, in a solution from figure, angle ECF is a central subtended angle by an arc EF, and we know that central subtended angle by minor arc is measure of that arc. Okay, that's why from figure, measure of arc EF equals angle ECF equals 70 degree. Since definition of measure of minor arc. Okay, that's why measure of arc EF will be 70 degree. Now arc DE, arc EF and arc DGF complete a circle, and we know that angular measure of circle is 360 degree. Let's apply here an arc addition property, and total angular measure of circle is 360 degree. Now measure of arc DE, measure of arc DE plus measure of arc EF plus measure of arc DGF equals 360 degree. Since arc addition property and angular measure of circle is 360 degree. Okay, and therefore let's put those values which we know. We don't know measure of arc D, that's why let's write it as it is. Measure of arc DE plus measure of arc EF is 70 degree plus measure of arc DGF is 200 degree, and that equals 360 degree, and therefore measure of arc DE plus 70 degree plus 200 degree gives us 270 degree, that equals 360 degree, and therefore measure of arc DE equals 360 degree minus 270 degree. Equal below equal. 0 minus 0 gives us 0. 7 cannot be subtracted through 6. That's why by taking carry from 3 we get 16 minus 7. 16 minus 7 gives us 9, and 2 minus 2 gives us 0. Okay. Equals 90 degree. Therefore measure of arc DE equals 90 degree. That is measure of arc DE equals 90 degree. Now we are interested to find measure of arc DEF. Now measure of arc DEF equals measure of arc DE plus measure of arc EF. Since arc addition axiom or property, we may say by arc addition property, equal below equal, measure of arc DE, which is 90 degree, plus measure of arc EF, which is 70 degree. 90 degree plus 70 degree gives us 160 degree. Equation second. Therefore, measure of arc DEF equals 160 degree. Question second. In figure, triangle QRS is an equilateral triangle. Prove that arc RS congruent arc QS congruent arc QR. Measure of arc QRS equals 240 degree. Okay. Let's mention its proof. Okay, here triangle QRS is an equilateral triangle. A triangle whose all sides are equal is called as equilateral triangle. That's why QR equals RS equals QS. These are the sides of triangle QRS, as well as these are chords of a circle. And as QR equals RS equals QS, we can mention chord QR congruent chord RS congruent chord QS. And we know that arcs corresponding to congruent chords are congruent, okay, in a circle or in congruent circles. We are going to apply that thing here, as well as we are going to apply arc addition property, and angular measure of circle is 360 degree here. Okay, proof. Here triangle QRS is equilateral triangle. And therefore QR equals RS equals QS. Since sides of equilateral triangle, but these are chords of a circle, that's why let's mention here therefore chord QR congruent chord RS congruent chord QS. Okay, and therefore arcs corresponding to congruent chords of a circle are congruent. That's why therefore arc QR congruent arc RS congruent arc QS. Equation first. Since arcs corresponding to congruent chords of a circle are congruent. Okay, and therefore let measure of arc QR equals measure of arc RS equals measure of arc QS equals X. Now measure of arc QR plus measure of arc RS plus measure of arc QS equals 360 degree dash dash. Since arc addition property and angular measure of circle is 360 degree, and therefore x plus x equals 360 degree, and therefore 3x equals 360 degree, and therefore x equals 360 degree divided by 3, that equals 120 degree, and therefore measure of arc QR plus equals measure of arc QR equals measure of arc RS equals measure of arc QS equals 120 degree. Equation second. Now we are interested to prove measure of arc QRS equals 240 degree. Now measure of arc QRS equals measure of arc QR plus measure of arc RS. Okay, by arc addition property. Okay, we have measure of arc QR as 120 degree and measure of arc RS as 120 degree. Let's put these values equals 120 degree plus 120 degree, 120 degree plus 120 degree gives us 240 degree. Equation third. Therefore measure of arc QRS equals 240 degree. Hence the proof. Question third. In figure, chord AB congruent chord CD, prove that arc AC congruent arc BD. Proof. Here chord AB congruent chord CD. Since given, if chords of a circle are congruent, then arcs corresponding to those congruent chords are congruent. Therefore, we may declare there an arc AB corresponding to chord AB and arc CD corresponding to chord CD are congruent. Let's mention here, therefore, arc AB is congruent with arc CD since arcs corresponding arcs corresponding to congruent chords of a circle or congruent circles are congruent. Okay, and therefore measure of arc AB equals measure of arc CD. Okay, but arc AB is made up of arc AC and arc CB, and arc CD is made up of arc CB and arc BD. Let's apply their property of addition of arcs. And therefore, instead of writing measure of arc AB, we are going to write measure of arc AC plus measure of arc CB. Therefore, measure of arc AC plus measure of arc CB equals measure of arc CD. We may write measure of arc CB plus measure of arc BD is equals measure of arc CB plus measure of arc BD. Okay, by arc addition property, or arc addition axiom. Now here you may note measure of arc CB is plus measure of arc CB at LHS as well as plus measure of arc CB at RHS. We may cancel these measure of arc CB, measure of arc CB, and therefore measure of arc AC equals measure of arc BD, measure of arc BD. And if measure of arcs of a circle are equal in a circle, then those arcs are congruent. Therefore, arc AC is congruent with arc BD. Hence the proof. Thank you.